The following is the description of the Geostationary Transfer Orbit Mission Flight Profile of the ILS Proton launch vehicle with the Eutelsat 3D communications satellite on board. The first three stages function to propel the orbital unit to a suborbital trajectory. The orbital unit consists of the BREEZE-M payload adapter system and the Eutelsat 3D satellite. The sequence starts with the ignition of the powerful first stage engines that output 2.4 million pounds of thrust at sea level. As the ILS Proton lifts off from its launch pad, it immediately executes a roll maneuver to align its flight launch azimuth to 61.3 degrees in order to achieve a parking orbit inclination of 51.5 degrees as it travels eastward. The engines fire for about 2 minutes, during which time the ILS Proton experiences maximum dynamic pressure. Then the first stage separation occurs. The second stage engines follow with nearly 540,000 pounds of thrust for 3.5 minutes, and then the third stage engine fires with 131,000 pounds of thrust for 4 minutes. The payload fairing is separated soon after third stage ignition, high above the Earth's dense atmosphere. At stage 3 separation, the orbital unit has traveled from Baikonur to Russia near the eastern edge of Kazakhstan at 51.5 degrees north latitude and is moving about 7,300 meters per second or 4.5 miles per second relative velocity. The upper stage of the ILS Proton rocket is called the BREEZE-M and is designed to inject payloads into a wide variety of target orbits. There are 5 BREEZE-M burns in this GTO mission design. The first BREEZE-M burn occurs about 2 minutes after the third stage separation, when the orbital unit is still in a suborbital trajectory. This burn will create a low Earth circular parking orbit with an altitude of 177 kilometers above the Earth. This 4.7-minute burn spans from Siberia to Russia's east coast. A half revolution later, the second BREEZE-M burn occurs to create the intermediate orbit. This burn centers the ascending node of the parking orbit, creating the first elliptical orbit and establishing the perigee location to be on the equatorial plane. This 17.7-minute burn spans from South Atlantic 800 miles east of Rio de Janeiro to Libya. 1 revolution later, the third and fourth BREEZE-M burns occur to create the transfer orbit. These 2 burns, separated by the jettisoning of the auxiliary propellant tank, greatly increase the apogee to closely match the geosynchronous altitude, making the orbit more elliptical and maintaining the equatorial plane perigee location. Both burns add up to 17.5 minutes and span from South Pacific, 200 miles west of Santiago, Chile, to 300 miles west of Morocco. During the coast phases, the BREEZE-M performs attitude maneuvers in order for the Eutelsat 3D's solar arrays to be exposed to the sun at a predetermined solar illumination angle, which is designed to satisfy its thermal and power requirements. During the 5th and final BREEZE-M burn, the orbital unit will perform a large plane change maneuver at apogee in the descending node from 49 degrees to 17.5 degrees inclination and will increase its perigee altitude to about 6,800 kilometers, maintaining the line of apsides on the equatorial plane in a 7.8-minute burn. About 13.9 minutes later, the Eutelsat 3D satellite is separated from the BREEZE-M to reach its targeted geostationary transfer orbit. The total mission time from launch to Eutelsat 3D spacecraft separation is approximately 9 hours and 13 minutes, and the total travel distance is approximately 4 times the circumference of the Earth.